All right, question F. The picture below shows the unit circle, where each point has coordinates cos x, sin x for some x, which of the following marked arcs corresponds to tan x less than cos x less than sin x. Okay, so the axes are sin x and cos x. You know, this is a classic definition of the trig ratios, because in GCSE you learned, well, okay, the definition of sine is opposite over hypotenuse, fine, you know, but that's sort of limited to angles less than 90, right? If you want to extend that, then you've got to use the definition of the unit circle, don't you? Yeah? Okay, so this is basically polar coordinates. So what do we have? Well, cos x less than sin x. Well, is that easy to deal with? Okay, maybe not. Oh, maybe it is actually. So let's do cos x less than sin x. Okay, so cos x is the x-axis, right? So cos x is the x-axis. So let's think of this as x. How about sin x? Well, sin x is the y-axis, right? So let's think of this as y. So basically we're asking, when is y greater than x, right? When is y greater than x? Well, then we could draw the line y equals to x, which is here. Y greater than x, right? Y greater than x means this top part up here. Yeah, makes sense? So for now, B, C, D are possible. Yeah, because y has to be greater than x. Yeah, the sin x has to be greater than the cos x. Brilliant. What next? So let's consider the next pair. So tan x, well, let's actually consider tan x and sin x. I think that might be actually a bit easier. Okay, so I can't erase my stuff for some reason, so let's do it here using another color. Okay, so tan x is less than sin x. Okay, what happens? So you know tan x is sine over cos, right? So the issue is cos is between 0 and 1. All right. So if you divide by a number between 0 and 1, then surely, you know, the thing gets bigger, right? So if sine and cos are both positive numbers, then we're sort of screwed, and that's not very good. But if it's a negative number, if for example sin x is a negative number, then that's good, right? Because if you divide by cos x, well, cos is between 0 to 1, then you get more negative, right? So dividing by cos makes the number more negative, i.e. smaller, right? So then if sine is negative and cos is positive, happy, right? Any other scenarios that we'll be happy with? We could also go sine positive and cos negative, yeah? Same logic as what we had up there, so that's also okay. Right, if sine and cos are both positive, well, at the start we said that that's impossible because dividing by number 0 to 1 makes it bigger, and same logic, yeah? If sine and cos are both negative, then again, the tangent will be positive and the sine is negative, right? So that doesn't make sense at all. Good, so we have two scenarios, yeah? Either sine is negative or cos is positive, so either this region is the happy region, well, but we already neglected that region because, you know, because y is greater than x, and the second possible region is when sine is positive and cos is negative, which is sine is positive, cos is negative, which is here, yeah? Which is this guy here. So that leaves us with the answer C. Yeah. Remember, we don't care about what this exact value here is. You know, where the arc ends, you know, no one cares. It's a multiple choice question. Yeah? In the exam, you're time pressured. Okay, so you've got to use all the ways to eliminate all the irrational options, and you're good. Okay, so if you're interested in calculating what that exact value is, you know, do go ahead. Yeah, it's not too hard, I think, as an inequality. But there you are. Yeah, that's how you eliminate all the other options.